Hi Year 12s. In this video we're looking at solving equations using trig graphs. So the first example that we're going to go through here is solving sine x. So just to sort of get an idea of what we're doing, we're going to start by plotting sine x. So you remember from my last video that it kind of looks like this. I'll sketch it out. So fairly rough sketch here. So that's roughly what sine x looks like. And we're solving it in degrees between the values of 0 and 360. So actually I really ought to change these measurements here out of radians and put them into degrees. So let's put those into degrees. So that would be, the OneNote wants to keep them. Okay, so if we put those into degrees, we'd have 90, 180, 270 and 360. Okay, and we can graph that on our calculator as well. So sine x, now at the moment that's in radians, so I want to change this into degrees. So I want it to go up to 360, and I want it to go from negative 1.5 to 1.5. And then we'll change it into degrees instead of radians. Okay, so there's my graph, and everything looks right so far. Now if it's equal to 0.5, that's like saying that there's another line going across at 0.35. So that line there would be y equals 0.5. And you can see that it crosses in two places in this interval. So there's two possible values that we can get. And so what we do is we put that equation into our calculator, 0.5, and we get that same line. And then we can g-solve for the intersection, point of intersection of those 2 points. So that first value is x equals 30, and that second value is x equals 150. And so when we're solving this equation, we would say that x equals 30 and or 150 degrees. And so there's two solutions in this case. Okay. Alright, so let's look at another example. This time we're looking at tan. So let's put that into our calculator to get an idea of what it looks like. So tan x. So there's what our graph looks like on this sort of limited scale. So kind of like that, and down like that, and like that. So that's y equals tan x. We'll just sketch in our asymptotes there as well, just to remind ourselves that it never has a value at that point. And then we'll sketch in a line for 1.2. So 1.2 would be around about here. Not a very straight line, but you get the idea. And you can see that it passes through this graph at 2 points here. So let's put 1.2 into our graphics calculator, and we can see we've got that similar thing going on here, and we can g-solve for the intercepts. So we've got 50.2, although I just noted that this time we should be working in radians, so we should change that first. So let's change our viewing window to go from 0 to 2 pi, and we'll also need to change back into radians. Okay, so our first point of intersection there is 0.876. So we'll put that one down. So x equals 0.876, and our next one is 4.017. We'll go 4.0.18. Okay, and those are our two possible solutions. So when you're doing these graphs, I'd suggest that you sketch them out first and show the line that you're solving with to get those points of intersection, and then put it onto your graphics calculator. And you can practice some of these in exercise 7.03. Thank you.